Continuing our investigation of a, h, and k, we have another function slightly different than the prior one. Before we had x squared plus 2, and that shifted the parabola up 2. What does x squared minus 5 do? Again, looking at our key values here for now. And it won't always be negative 4, negative 3, negative 2, negative 1, 0. Just for now, I know this is a good place to start. And so negative 4 squared minus 5 is 11. Negative 3 squared minus 5 is 4. Negative 2 squared minus 5 is negative 1. Negative 1 squared minus 5 is negative 4. 0 squared minus 5 is negative 5. And then 1 squared is the same as negative 1 squared. So that should give me negative 4. Negative 1, 4, and 11. Okay, so now I can graph this. At negative 4, I go up to 11. Negative 3, I go up to 4. Then at negative 2, I go to negative 1. Negative 4. Does that seem right? I feel like I must have done something wrong here. No, I guess that's right. Negative 5, negative 4, negative 1, up to 4, and up to 11. Look at that. Looks like a parabola. So again, how does it differ from my parent function, y equals x squared? Well, those values were 16, 9, 4, 1, 0, 1, 4, 9, 16. So how does this column from the parent function differ from our new y value? Hopefully you can see the pattern that the new one is 5 less, which of course makes sense because if you were to take it and shift it up 5, you would have gotten our parent function. But since it wasn't shifted, it was shifted down 5, it lands right there. So basically it's like I'm graphing my parent function and then shifting it down. Again, the pattern still holds. From the vertex, you're going plus 1, plus 3, plus 5, plus 7 in both directions. So your line of symmetry is still x equals 0, as in both of the prior examples. And your vertex is now 0, negative 5. Now let's rewrite this function in our a, h, and k format. This is y equals 1 times x minus 0 squared minus 5. And you'll notice again, it seems like this h has something to do with my x value of my vertex, and this k has something to do with that. Looking at this example and then looking at the prior examples at Wells, it seems like hk has something to do with my vertex. So maybe I'll start to write that. H comma k, I won't write capital, I'll write lowercase, hk is my vertex. So not only does k shifted up or down, but I'm guessing now that hk actually determines my vertex, and then my jump pattern seems to always be 1, 3, 5, 7, 9, so I'm not quite sure what a does. But that's where I'm going so far. It's my guess. We'll see if the pattern holds that h and k determines the vertex. And it seems like h is my line of symmetry. Like x equals h.